फटाफट बेसिक चेक कर लेते हैं गाइस, चल रहा है कुछ। Okay, hello everyone. I guess we are ready to get started. Get the notification. Nice music. Good. Chalo. So you have helped a lot. Placement lag gayi ab. Lag jaye ab. Okay, chalo. Good. Best of luck for placement. Okay, so we are gonna talk about some good problems. मेरे को specifically, I am looking forward to uh, like discuss one specific problem which I felt was very interesting. Uh, where D Shaw OA intern में segment tree आया था. Yes, I think these are very common, right? Nowadays, I think most of you guys would have an idea that OA में क्या आता है. Okay, but good to see so many of you back. Yeah, I'm doing live stream after a long time, I feel. uh, I'm back to Bangalore now, so I can afford more time. Was back at home, तो वहाँ पर live stream करना उतना feasible नहीं होता है. Little bit net issues and all these things. Trees, yeah. So graph, trees, segment tree, DP. These are like the decider questions of almost all OAs, right? And today we'll probably learn very interesting trick that I think many of you might not know. That's why the title. I bet you didn't know this bit trick, right? I want to understand geometry problem more than Fenwick. I want to understand how to clearly implement it. Yeah, we'll look at that. We'll look at that. I think I haven't seen the second question. I know that it's of geometry, but I did not see it. I saw it on some LinkedIn post. But the first question, like I was taking a bit manipulation class, and that day only there was like last Saturday I was taking a bit manipulation class, and that day only like there was someone who shared ki Vivek, today only there was a bit manipulation question. I was like, okay, this is a very good question, and I'm here today, in fact, probably to discuss that one question. Okay, because I think I can show you a very beautiful trick that you can use in many more techniques like that. उसके ऐसा बहुत problems बनता है, and it's like a very good idea that you can keep in mind. Okay, I mean many of you who come to my channel usually know that I take the harder problems, है ना, harder questions ही discuss करते हैं हम लोग mostly तो. Okay, let me share my screen. So last two problems as usual, because there are two contests. So we'll do last two questions today, and we'll look at how can we possibly think about it. 5 years gap, what should I do? There are ways which you can manage this, but I think मैं अभी तो chat पे नहीं बता सकता. ठीक है. There are legal ways तो यही है कि पढ़ाई करके startup में job लो. Is this bit trick already taught in this? Yeah, a form of this I was covering, and I'll teach you one notch up of that. So there are 6 fundamental bit tricks that I've covered, but not exactly this one, a small tweak of it. Isliye I wanted to cover it. Beaten? No, not yet. Cheater got place at first company, he can't even solve prime number code. क्या interview के अंधे होते हैं क्या? Here I think this cheating and all, it's an endless discussion. कितना भी बात करे कोई फायदा नहीं है, ठीक है. I think eventually everybody will come to their place. I was talking to someone very knowledgeable, and he told me that and I also agree कि आज तक हमने किसी को नहीं देखा जो बहुत अच्छा है and वो within next 2 years अच्छे जगह पे नहीं पहुंच गया. मतलब ऐसा बहुत ही rarely होता है. Okay. तो don't think of immediate values. मतलब you will not even like तुम्हारा जो कॉम्पेंसेशन, जो तुम मतलब जो लोग सॉफ्टवेयर में आते हैं ना, पैसे कमाने हैं, ये सब चीजें जो भी सोचते हैं, तो तुम पैसे एक्चुअली स्टार्ट के 2 ईयर में तो नहीं कमाते हो. आई कैन टेल यू दैट. ओके, इवेंचुअली इट गेट्स टू अ गुड नंबर. ओके, सो यार जो कंपनी चीटिंग नहीं रोक पा रही है वो कंपनी की तो खत्म होने में ज्यादा टाइम नहीं लगेगा उन कंपनीज को, ठीक है, टेंशन मत लो। तुम्हें क्या लगता है जो कोड नहीं कर पा रहा है वो कंपनी में जाके क्या करेगा? मतलब आई डोंट नो यू गाइस अंडरस्टैंड दिस और नॉट, बट इवन आफ्टर गोइंग इनटू कंपनीज देयर इज सम इंटेलेक्ट रिक्वायर्ड टू वर्क। ऐसा नहीं होता है, और जिनका नहीं होता है वो कभी प्रमोट भी नहीं होते उन कंपनीज में, ठीक है। मतलब आई डोंट नो इफ यू रियलाइज दिस और नॉट, मतलब तुम पहुंच भी गए कंपनी में तो तुम कर नहीं पाओगे, मतलब इट्स नॉट पॉसिबल। पॉलिटिक्स से नहीं होता है हर कंपनी यार। इट इज ओनली पॉसिबल इन अ टीम जहां पर जो तुम्हारा सुपी जो एकदम मैनेजर लेवल पे है वो अगर उतनी कॉम्पिटेंस नहीं रखता हो, बट हाईली कॉम्पिटेंट टीम्स पे तुम कभी पॉलिटिक्स से नहीं कम सिर्फ जी सकते। ओके, तो डोंट वरी अबाउट चीटिंग एंड ऑल, थिंक अबाउट कि हाउ कैन यू इंप्रूव, दैट्स इट, क्योंकि वो तुम्हारे कंट्रोल में है ना। ये तो आई थिंक आई माइट कोट गीता, बट है ना, कर्मण्येवाधिकारस्ते मां फलेषु कदाचन, जो श्लोक है कि फल की चिंता मत करो, वो इवेंचुअली यू विल रीच टू द प्लेस। ओके, सो let's look at the last two problems. Pehle, like, let's start with how many questions did you guys solve? So I hope I had asked you to take a look. So how many questions did you solve in bi-weekly first, comma, how many questions did you solve in weekly? Just throw it in the chat. Let's see how many of you are able to do this. So how many questions were you able to solve in bi-weekly and then in weekly? Comma deke nahi diya to dash. 3,2, 3,4, 3,2, 3,2. Okay, most of you guys 2,3. Okay, 3 in weekly. Okay, 3,2. So what I understand is most of you have solved two problems. So I'll look at the last two problems of both the contests because there are already like too many problems to discuss. Yeah, okay, that's fine. Like if you missed something, that's fine. But I think potentially you should have been like in my streams. The the level of bar is that you should be able to solve the first two problems and you come to learn the last two problems. Okay? So we'll look at these two problems and we'll try to understand how could you have solved the problem, right? And we'll start with bi-weekly and then we'll go to weekly. Okay, yeah, trapezium and all will understand. I think this last question is trapezoid, right? I will understand that, don't worry. We'll look at all the four problems. Okay, so let's get started. Guys, don't focus on दूसरों से कैसे हो गया, फोकस ऑन मुझसे क्यों नहीं हुआ, ठीक है, एंड व्हाट शुड आई लर्न टू बी एबल टू सॉल्व दिस क्वेश्चन। दैट शुड बी योर प्राइम गोल इन योर माइंड, कि मैं ऐसा क्या सीखूं जिससे मुझसे ये प्रॉब्लम सॉल्व हो जाए। ओके, या मे बी विल डिस्कस द वीकली टू शॉर्टली। Okay, let's start everyone. Let's start discussing the problems, and my personal favorite is probably this problem, which I want to look at, and I want to probably solve even I'm going to teach you how to maybe solve higher version of this, like what I call is bit count profiling, right? I think this is something I'll teach you, and it's a very good technique, and I don't know how many of you know that. Okay, let's start everyone. Shall we? Quick +1 in the chat and we'll start. And before we start, stream को एक like कर दो, usual YouTuber stuff. Okay, so let's start with the first problem, and I have not read this problem, so we'll start with this. We have n nodes and like numbered from 0 to n minus 1, and there is 2D array of m length. So n nodes, m edges. There is some cost of each edge. So a weighted, indicating a one-way communication. So directed weighted graph is given. So see, this is how you read. As soon as I'm reading this paragraph, my mind is saying I'm dealing with a weighted directed graph. Some nodes may be offline. Your Boolean array, where online means true, means okay. Some nodes are on, turned off and on. A path 0 to n minus 1 is valid if all intermediate nodes are online. The total recovery cost of all edges in the path doesn't exceed k. Okay. For each valid path, define its score as the minimum edge cost across the path. Okay, minimum edge cost across the path. Find the maximum path. So minimize the maximum, or sorry, return the maximum path cost. So maximize the minimum. Okay. Do you get the term? There is something defined as minimum of some things, and you have to maximize this. What should this indicate to you directly? ये तो मेरे पढ़ाए हुए टॉपिक्स में से, राइट? बाइनरी सर्च which is freely available for you all to read as well. As soon as you see maximize the minimum, the first thing should click is binary search, right? I have not even thought about the problem yet, but I'm understanding that there is some function जहां पर maximize the minimum hai, and probably binary search is the first thing I'll think about. Okay, so that is there, and if no valid path exists, then return -1. So my understanding is this will be binary search on answer. Probably my first hit would be binary search on answer, and then I have to check connectivity between two nodes. So some sort of Dijkstra or some sort of BFS will be there. That's my thought, and maybe that might be the case. So we'll try to dissect it up, right? So a path is valid if total recovery cost of all edges does not exceed k. Let's look at the constraints quickly. K is fairly large, so this has to be in the values, and n is also large, so it's like big graph itself. No constraint is small. Okay. So for each valid path, define its score as minimum edge cost along the path. Okay. So score as minimum edge cost along the path. Minimum edge cost along the path. So what is the minimum? If I know what is the minimum, then I can delete all the edges below that particular value. If you are binary searching on a particular answer and that is your minimum, then everything below this is no longer available. Then you have to find the shortest path whose cost is less than equal to k. So is there a shortest path with value less than equal to k? So now my idea is, so see, how did I decode the problem? Did you all see ki kitna, like I just looked at this problem for 3 minutes. Did you understand how did I decode it? I'm trying to show you as much of my brain work as possible so that you can also do this replicated on your side. Yeah, question 3 was, I mean, easy, but you should know how to think about it fast. Don't try to always think ki, okay, solve ho gaya. You should also be thinking ki, how could I come to the solution faster, right? So as soon as I see maximize the minimum, it's a binary search on answer type of question. So if I know the answer, if I know the maximum path score, which is the minimum edge, so if my minimum edge is x, everything less than x is deleted from the graph. No, this problem I am seeing the first time. The next problem I have read already, because that somebody showed me in my class ki, Vivek, can you solve this problem? And then I was like, ki, I have to take this live stream because I have to teach the technique. Okay. This isn't too hard for me because there is a very similar problem we also give, which is binary search on answer, and then there is some BFS idea. Like, so I have seen similar ideas before. Okay, so this is minimum edge cost, maximum path score. So if you are binary searching on answer and your answer is x, so if you are not able to understand what I'm saying just now, why is this binary search answer, you should definitely study binary search more. If you were not able to solve this problem, believe me, you need to study binary search more, and the binary search material for that on mang.in is absolutely free. So that is obviously, I have taught the framework, so I can vouch for it. The material there you can refer to, and you will learn the framework for binary search, that how to think about binary search on answer, right? This course, guys, you guys can complete. This should give you binary search on answers full idea. Okay, this I'll link for everyone. Anyways, I think people who are on my stream know these things. So binary search on answer, and then in the graph I have to figure out all immediate nodes are online. So basically nodes that are, what does offline nodes then do? Is there any work of offline nodes? No, there is no work of offline nodes. So I can delete those nodes technically, because it is maximize the minimum. That's why it's binary search on answer. Okay, so now you will, for a particular x, you will build a new graph which contains only edges with weight greater than equal to x, because that's the minimum, and you have to keep only the online nodes, and you have to check if the shortest path from 0 to n-1, this is the check, is less than equal to k distance. This is the check. Once you set this graph, run a Dijkstra on this graph, What is meant by recovery cost? What is the recovery cost here? I did not even read that. Recovery cost is like uh, the edge cost to traverse that. You did using max heap plus Dijkstra type of question. Yeah, I think you can maintain. There is another one thing. I'm going to come to that. Yes, yes, you are saying what you're saying is I understand. I'll come to that. I think this should be the direct ideal solution. But yeah, you can maintain the minimum seen in the path also. Uh, how would you actually graph bar construction so we can just modify the traversal in the Dijkstra? Yeah, I mean, you don't need to create this graph. I mean, in the code, you can pass the X value and not traverse that edge. That's what you mean, right, Jasimus? That if you are passing this X, then you, like while doing Dijkstra, you cannot traverse the edge that is more than X. That's something like that, right? Yeah, that's true. But you have to do the binary search. But you have to do binary search plus Dijkstra. I mean, you cannot do it with just Dijkstra, I think. Okay. So if you could not think that this is a Dijkstra, then you need to practice more of shortest path question. Okay. If you could not solve it with Dijkstra, you need to practice more shortest path problem. This is a pure shortest path modeling problem. Very easy modeling problem actually. We have discussed harder problems, right? And this is binary search. Why? Because maximize the minimum. I've told the course also, right? Uh, yeah, maybe you can send me. I'll have a look at the code at the end. Okay. So once you think about binary search plus Dijkstra, then you need to code this. Uh, yeah, topo sort might also be possible. Okay, you are given a DAG. Okay. Yeah. If you have a DAG, I did not read that. If you have a DAG, then you can use a DP. Yeah, makes sense. If you are given a directed acyclic graph, then you can use a DP also to find the shortest path. This shortest path can be solved using DP also if you don't have a cycle in the graph. Correct. That's why many of your codes that you are seeing with other logics were working with DP and all. Yeah, toposort and DP. Yeah. Okay. I think I'll look at Laksh's code on this. Leetcode I don't have logged in. I don't give the content, so I just haven't really logged in a longest time, I feel. But yeah, let's look at Jasimus code. Yeah, I think Dijkstra was not intended. You also did not read, I feel, that it's a DAG. So you could have done it with DP. But basically, if you have a binary search that min max and then you are pushing, if both of them are online, then only that edge makes sense, because offline edges are anyways like deleted nodes. Then you build the graph and then you do from L min to max, do the Dijkstra, do the binary search and check if in the graph you can do the k or not. Like if with this particular mid greater than equal to mid edges, you can you solve the problem or not. And in Dijkstra, he's just trying to find the distance of the n minus 1 node from the source node 0, and if that distance is less than equal to k. Clear, everyone? And since this is a DAG, you don't need to use Dijkstra. You can use topological ordering also, right? That you can find the topological ordering and then you can find the values slowly. I mean, in DP order, basically. Okay, so this is essentially the idea for third. This is a doable problem. If you have practiced enough binary search and Dijkstra, you should have been able to solve this. These type of questions have come before. Yeah, it's in the contest, Aditya, if you haven't solved it. Yeah, guys, I'll have to quickly pick that up. Sorry guys, let's resume back. टोपोसॉर्ट से कैसे करोगे? लाइक फ्रॉम टोपोसॉर्ट फर्स्ट सॉल्व द फर्स्ट एजेस जहां तक डिस्टेंस है, यू नो. ओके. ओके. How to solve it toposort? You can build the topological ordering, and from there you can suppose this is the first. What does topological ordering does? It tells you the order in which you should find the distances. That's it. तो उस ऑर्डर में एजेस को तुम्हें मतलब प्रोसेस करना है बेसिकली. रिलैक्सेशन जो तुम करते हो ना डाइक्स्ट्रा में, यू टेक आउट द शॉर्टेस्ट फर्स्ट, उसमें उस ऑर्डर में कर दो बस. दैट्स इट. अभी तो जैसे मसा कोड दिखाया पास कर रहा है. Why are you so saying कि नहीं पास कर रहा है? Yeah, DFS and DP will work, correct. Chalo, let's move to the next problem. I think that should be clear. Yeah, if you build the graph every time, yeah, that is true. It will not work. Okay. Next करे. Okay, chalo. So probably this is the problem that I had titled for, है ना? Because there are many ways to maybe solve this problem, and some of you might have solved this using permutation combination and stuff. But maybe I'll try to show you a very beautiful technique that I once learned, and which is applicable in this problem. And I feel more people should know about it. That's it. Okay. So this is one problem that I feel was really good. Digit DP and all, nothing is required. It's just a simple no digit DP. It's a pure recurrence question. Okay. Pure recurrence can solve this question, and there is a very beautiful trick behind this question. Okay. Let's try to solve this problem. Okay. Very, very simple bit manipulation observation question. Okay. This is a normal DP problem. Commit and then solve the next one with vector of Fenwick tree. Next one, as in, was there a 2 also? Kya? Oh, okay. Okay. Acha, I did not see this, that there is a 2 version also. Okay. So maybe I'll see the 2 later. Let's first solve the. Which one is easier? 1 is easier or 2 is? I think this one should be tougher because the constraints are way higher. This is, I think, lower constraint or what? Same only. Okay, we'll see. Okay, we'll see. I have not seen the 2 problem at all. I just saw this problem because somebody sent me in live class only, and I was discussing. Let's discuss this on YouTube live stream. Okay, so this is actually a very beautiful problem, and there is a simple observation behind it. The first level observation, and second level, there is a beautiful idea of recurrences that you should know. Number one, that pop count chain kind of converges very, very quickly, right? Like the first pop count will make it like maybe what 50, 60 value, like something like that, right? Like whatever is the number up to 10 to the power 18, it can have at most 64 bits and 60 bits, right? 64 bits, let's say maximum. I don't want to count even also, right? So like 10 to the power 15 is same as, so 2 to the power 3 is approximately 10, right? And 2 to the power 10 is 10 to the power 3. So this is 10 to the power 3, 5, this is 5. So this is 2 to the power 50, right? So there will be 50 bits till this much. Okay. So we are dealing with 50 bits over here. These are two approximations that I know, that 2 to the power 10, which is 1024, is approximately 10 to the power 3. So from here, if you do 5, you will get 15. So over here also it's 5, so it's 2 to the power 50. Clear, everyone? So you know that there are 50 bits in the number. Sorry, let's go back to the problem. So in the, like whatever is the number in the first bit count, also only it will become 50, less than equal to 50, and then it's easy to find the length. Okay, this is easy to find length. Okay, so I don't care about the length. The problem that I want to solve is, if you can find in 1 to n how many numbers have bit count equal to 0, bit count equal to 1, 2 up till 50. If you can get this count, can you solve the rest of the problem easily? How many numbers have 0 bits on? How many numbers have 1 bits on? How many numbers have 2 bits on? How many numbers have 50 bits on? If you can figure out in 1 to n how many of the numbers are like that, can you then solve the problem, rest of the problem? Because each of these will have a fixed sequence of how many moves it will be required after that. Correct, everyone? Does this make sense to everyone? That in 1 to n, or say 0 to n, right? In 0 to n, how many numbers have 0 bits on? How many numbers have 1 bits on? Like, so example, if you write, let's try to write some profiles. 0 0 0 0 0 0 0 1 0 0 1 0. I'm just writing it so that you guys can understand the what I'm trying to say. 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0 1 1 1 1 0 0 0. I don't want to go ahead anymore, but let's write till the board finishes. Okay, so this is like 0 1 2 3 4 5 6 7 8 9 10, right? So for every number we can count how many bits are there. Like this has 0, this has 1, this has 1, this has 2, this has 1, this has 2, this has 2, this has 3. So if you say how many numbers are there till 0 to n, if I can kind of count the number of numbers, like 0 has one number which is 0, there are 1 2 3 numbers which are 1, there are like 3 numbers which are 2, and there are one number which is 3. Sorry, one number has 0, 3 numbers have 1, 3 numbers have 2, 1 numbers have 3, right? Isn't it similar to how many did once? Yeah, we did the cyclic positional, we did the contribution technique of each position in the class, right? I think for those who are mentioning this cyclic property, in the class I was teaching contribution technique of each position, but it's a little different from that, what I'm teaching today. Okay. So did you everybody understand what do I mean to say? Ki from 0 to n, create a profile of how many numbers have 0 bits, 1 bits, 2 bits. Did everybody understand what we are trying to create? First, I need a +1 in the chat for this, and then I'll teach you the beautiful idea. Quick yes in the chat, and then I'll teach you how to do this. How to check the limit n. N is up to like 10 to the power 15 in the problem, right? So we will do till 2, like there might be 50 bits at max. Okay. Now look at this very, very carefully. If you think about, say, up till 7, I want to calculate. Okay. Isn't it like 0 to 3, the same thing wrapped around with one more 1 in the front? Yes or no? Is it this same as this with one more 1 wrapped around with 0 with 1 in front? Yes or no? So if I want to calculate till say 7, can I calculate till 3? The profile is, say, there are 0 bits in one number, 1 bit in two number, 2 bits in one number, right? So if 0 to 3 this was the case, for 0 to 7 what will happen is you will have these plus these same, like all of them will have 1 in front of them. So 1, 2, 3 with the same profile in with them. Does this make sense to everyone? How do you, from, if you know the profile from 0 to 3, you can get the value, like, and if you merge them, it will become 0 has 1, 1 has 3, 2 has 3, 3 has 1. Okay. Did everybody understand how can we go from 0 to 3 to 0 to 7? How many of you understood this idea that if you know the answer from 0 to 3, which you can calculate from 0 to 1, if you do just this is nothing but 1 wrapped in front of 0 to 1. So if you, for this, you know 0 bits 1, 1 bit 1, from here it is nothing, like this will be nothing but this plus 1 bit 1, 2 bit 1. In 0 to 1 range, there is one number which has 0 bit, one number which has 1 bit. So in 1 to 2, it will be the same thing with all of them having a 1 in front. So in 1 to 2, you will have one number having 1 bit on, like 1 bit on, and there is one number which has 2 bits on. 2 bits on wala, how many number is there? 1. So if you add these two in map, you can get this profile. And from this, you can shift it by 1 and you will get the profile for 0 to 7. So somehow 2 to the power n's 1 can be solved, right? Somewhere this can be solved. Okay. We still haven't come to the best idea. I'll teach you the best idea. This is for 2 to the power 1s. And now how do you solve for general n? Because this can be done in almost any recurrence. Okay. So now if you have, say, okay, I'll not really change the slide. I'll go over here and maybe delete some of this. I should have made a copy before, but anyways, I hope you guys are getting the idea. These are the frequency of how many numbers has that much pop count. Okay. This is basically the pop count numbers. And 3 bits have set bit count as 1. Yes, number of count set bit is 1. So if you, let's suppose somebody gives you, like, somebody tells you to calculate for 10. Okay. Somebody calculates you to calculate the answer for 0 to 10. Okay. Can I say that it will be nothing but 0 to 7 plus 8 to 10? Okay. Now, this is one thing that we can calculate using that doubling logic. We know that now. For this part, if you see, isn't it 1 wrapped in front of the previous period's 3 numbers? Like if you are like in this range, the first half gets completely covered, like 2 to the power's first part gets completely covered, and the next power of 2 is partially covered. So it is nothing but 1 in front of something in the previous period itself. Okay. So this we can write as like shift, like I mean to say, I'll just call this as shift operation on 0 to 2. Like calculate the answer for 0 to 2 and then shift it by 1 because there is a 1 in front of all of them. Okay. Clear till this point? So to calculate 0 to 10, you need the answer of 0 to 7 and 0 to 2. So you are basically breaking some f of n into some f of 2 to the power k minus 1, some f of k to the power 1, plus f of some number x which is at least half the size. Okay. you are breaking down into f of like this k will be 7, like you are going till this 7 over here, so some fixed 2 power wala thing, 8 numbers, and then the rest would be from, at least it will be less than this size for sure, it will be less than this number whatever is over here. Okay, less than equal to. So if you can pre-calculate these things, it's like a recurrence that is halving in size every time you are calling it. And that, my friend, directly just gives you a log n solution, log n into 50 kind of solution. Because every time you are calculating some fixed powers, like you will only need things related to 0 to 1, 0 to 0, 0 to 3, 0 to 7. These things you can memorize and save like DP. And the rest of the recurrence that you are calculating will always half in size. So you will in log n steps reach to a very small number. And this shift takes O of like 50 size. So calculating this recurrence is O of 50. So this is 50 into log n complexity. So you could have just written a simple DP kind of code which memorizes the required relations. And the fact of the matter is you only need powers of 2's and like power of 2's minus 1 in this case. If you see the range, number of elements in the range, it's 2 to the power 3 only. Okay. But this is one technique that I feel which can solve any problem. This technique actually originates from an optimization on matrix exponentiation on DP. I'll like anytime you can like break a number into 2 to the power some decompositions, right? 2 to the power 1, 2 to the power 3, and so on. So you have to think about how can you break into smaller forms of 2's and pre-calculate some certain small values only. Okay. So this is a recurrence, like whenever you have this property that things repeat in 2's powers, you can always use this kind of logic where you make some, like you will only need smaller 2 powers and the bigger things can be partially covered and it will be a log in recurrence. So what I mean to say, if you are trying to code this, I mean, if I had to code this, probably I would have written like void calculate like integer n, like calculate the values from some, maybe, I mean, I could have done it in a different way also, but like 0 to n, right? So you will figure out that name of this technique koi name nahi hai bhai. It's just an observation that I've seen, that I've used in some problem I remember before, but it's a very beautiful observation. Okay. Let's say for an example, suppose you were asked to calculate. I'll show one more example. Suppose you were supposed to calculate 0 to 14. So this will break down into 0 to 7 and 7 to 14. But ye jo 7 to 8 to 14. But this 8 to 14 will be nothing but 1 wrapped in front of 0 to 6. So you can write it as shift of 0 to 6, and it's like this number halved in size at least. Okay. And then this again will be another recurrence call and it will calculate its value easily. I sometimes call it bit profiling, because this is a technique which allows me to calculate from L to R how many numbers have how many bits on. If you have to ever get how many numbers have how much bits on, if you have to pop count for numbers in the range L to R, you can use this technique, because you can calculate from 0 to R and then subtract 0 to L, and that will give you the number of numbers in the range L to R, which will have like how many numbers will have how many bits on. You will get that profile, and then you can use it for some next problem, next thing asked in the question and all. इससे अब क्वेश्चन कैसे सॉल्व होगा? अरे दादा, फिर तो आप So now if you know ki if the question was 7, n equal to 7, if you know that there are 0 bits on in one number, 1 bits on in 3 number, 2 bits on in 3 numbers, and 3 bits on in one number. If you know this, then, and from 1 bit it takes how many steps to go to 0, from 2 it takes how many steps to go to 0, from 3 how many steps, that you can brute force and calculate. So you will know that these many numbers will take that many number of steps, this many numbers will take that many number of steps, right, and so on. Okay. Overwhelming? Yeah, I mean, like, you can go with traditional techniques that you could have used, uh, like digit dp plus bit mask and all, but I think they are also fairly complicated if you have to learn them. So why not learn another good recurrence technique that helps you solve this problem? Okay, so this is another technique that you can use. Okay, I think build on top of this, I can give you a rough pseudo code that if you want to calculate, you can use a dp, like dp, where you will return a vector, right, and till, like, you can maintain a map of I'm getting lazy, but you can, right, so you can maintain. So if you are having a n, like if this is a power of 2, then you can basically then the way to calculate this is nothing but you will do, I'm not writing the exact code, I'm writing assuming that this is, let's say, 7. So then you will do temp by 2, 7 by 2 will be 3, right? So if you get this temp, the final answer will be equal to temp, and then, like, it will have always 50 bits. So I can go through integer I equal to 0, I is less than 49, I plus plus, and answer of I plus 1 plus equals to temp of I, something like this I can shift. So all these things will be shifted by one more bit and add it into the answer and then return answer. This will be only if n is of the form 2 to the power n minus 1, and I can cache this. I don't want to calculate this multiple times also. Okay, and for other numbers like 14, I have to calculate the power of 2 just less than it. Power of 2 just less than this. How do you get that? How do you get the power of 2 just less than this number? How do you get power of this just less than this number? Yeah, most significant bit. How do you get that? Yeah, log. Actually correct, log. Okay, so I don't know if you guys know this or not, but built in, like, you can learn about this. Google this, that what is underscore underscore built in count leading zeros. Okay, built in count leading zeros, LL version you can do. And then this is like, this will give 31 minus this will give you for integer numbers, and then you can do something with that, like 64 63 minus this if you use the LL version. Okay, get MSB. So nowadays you are like these things, so you can also figure out if you don't have an idea key, how do you do this, that MSB of a LL number using bit count, built-in CLZ LLX in C++. So if you want to learn that, I'm not figuring out the details of the implementation. right? But this is essentially how you can get the like MSB index, and then you can get you can shift it back using a long, and you can get this. Yeah, yeah. Bit width is also there in C++ 20 plus, I think 17. I don't remember exactly. Yeah. So this is how you can get this. Like if you have a bit number, you can calculate the index easily, and you can get the mask also. So this is how you use. This is how you can get the power of 2 just less than this. Okay. कि जैजिमस का प्रोफाइल, लोगों को जैजिमस का प्रोफाइल चाहिए सबको. जैजिमस जी भेज दे क्या चैट पे? Yeah, right. This is how you calculate log also. Log floor. है ना? This is how you get it. Okay. I don't want to get too deep into this for today. Yeah, this is guard. This is also important thing because built-in 0 is undefined. Log of 0 is undefined, right? So I don't want to get into that. So learn this. This will help you calculate. Like if you give 10, it will give you 8. So you can use whatever answer you are getting minus 1 over here, and that to the number n you can do in the recurrence. A built-in Popcount gives you the number of on bits. We are trying to calculate for 10, which is the previous power of 2, like 8. Okay. तो उसके पहले तक we'll do the recurrence, and उसके बाद का we'll do the partial coverage. How to approach a similar problem? After solving this question, you should remember this technique. That's how you can approach similar questions in future. Or guess. Okay, bit is a very important technique. I think there are only 6-7 ideas in bit manipulation that can possibly come. This was there. Okay, this was one of them. Okay, clear till this point, everyone? I think one thing I can do is I can add Jasimus as moderator. That should do the trick. सबको कितना मिथ है बेस्ट डीएसए टीचर का. ठीक है यार, ऐसा कुछ नहीं यार, सबको ही बेस्ट है, सबको अपने अपने लेवल पे अच्छा पढ़ा रहे हैं यार, राइट? I don't know why, but like there was one student who sent me a screenshot compare Vivek Gupta's teaching DSA teaching with other teachers of DSA on ChatGPT. मैं बोला भाई ये क्या भेज रहे हो? Okay, clear till this point? This idea, try to implement this. I showed you how to do this in a recursive way for a power of n. But if you are not power of n, then you will have to do the thing that I told. इसको सोच के properly implement करो. Believe me, you will remember this forever. अभी मैं कोड ऐसा टाइप कर दूंगा, तुम देख के सेम टाइप कर दोगे, कुछ नहीं होने वाला जिंदगी में. Okay, clear all? Let's move to the next problem. यार this is बेकार क्वेश्चन. इसके लिए I made 6 Fenwick trees. Why not in one node keep 50 values? ये क्या कर दिया तुमने? ये मतलब why not in one segment tree node 5 values? Yeah. Yes, 5 you can keep, no? बट भैया ये बहुत इंपॉर्टेंट है. नहीं यार, आई थिंक किसी को C++ नहीं आता तो मैं उसका कुछ हेल्प नहीं कर पाऊंगा. बट लोग जब ऐसे मतलब लोग जब बेसिक डीएसए sheets वगैरह करके आते हैं, then I think I can help them better. मतलब that is generally the place where even I am more impactful. Okay. Okay, chalo. So this problem directly feels that you have to do the same thing, but for a range query point update. Seems like a standard segmentary problem. Like, but in the L2R, you have to point the pop count depth. So yeah, this is easier problem. Yeah, now I understand why you were saying that this was easier. Okay, so for every number, we like in O of 5, can you calculate its depth? Yes or no? For any number x, if I do, like, if you just have to count, right, okay, how many steps it takes to get to 1. So in order 5, you can calculate its depth. Correct? Yes or no? For every number in order 5, by using built-in Popcount LL only, you can calculate in order 5 what is there. And then instead of this original array, we will create an array जिसमें we will keep the depth of each positions. That ith number का depth is 1, इसका 2, इसका 1, इसका 5, इसका 3, इसका 2, इसका 5, इसका 1, right? And then you build, like, because there are range queries, you will build a segment tree where each node will contain the frequency of how many are 1, how many are 2, 3, 4, 5. Acha, you did not know about LL wala thing kya? Okay, that's why I'm saying built-in pop count LL, because I have also gotten wrong answer in some question. Built-in, I hope you guys know that there is something called as built-in pop count, but don't use it on long numbers. There is something called as LL version also, which uses on long. Okay. So this is a standard segment tree where you have to maintain frequency of each value in the range. Okay. But yeah, I am stuck in pupil. By streams देखो भाई, if you, I can guarantee, like, AZ का course वगैरह तो वो सब चीजें तो है ही, but I can guarantee if somebody watches all my streams and understands all the idea, तो rating बढ़ने में ज़्यादा time नहीं लगेगा. ठीक है, बहुत idea सिखा रखे हैं, right? And yeah, you can do it with ordered set also, that if you're like kind of keeping a merge sort tree kind of thing, like you're maintaining how, like, the values in those ordered sets, and you can get the frequency in each node. Yes, you can do that also. But I think the easier way would be to maintain a frequency map in each node and merge two frequency maps. Right. Okay. That इधर 4 नोड का एक नोड है, इसमें 1 is 2 times, 2 is 1 times, 5 is 1 time. Here 3 is 1 time, 2 is 1 time, 5 is 1 time, 1 is 1 time. When you merge these two nodes, you will maintain another node, which is 1 is 3 times, like just add the frequencies. Yeah, PVDS plus binary search will also work. Yeah, I think what do you mean by that? I understand. Yeah. Like, you maintain the positions, like if you maintain in an ordered set, the positions of 1, positions of 2, positions of 3, 4, 5, right? And then if you want to get from L to R how many are K, in the list of K, binary search for L, binary search for R, and you will get the number of elements in L to R. That is another way in which you can solve if you have ordered set done, or else it's a standard segment tree question by default if you don't have ordered set available. Yeah. In normal sets, you cannot get the number of elements in the range L to R, even after doing binary search. Okay, cool. So this is also another technique. This was, I think, covered also in one set problem, but this update needs ordered set. If you have static data, then you can do this using normal sets also. Okay. This is a standard segment tree problem. Even I used vector of Fenwick trees. You guys are doing too much overkill. I don't know why. Like in Fenwick tree also, you could have saved a vector or a map or something like that. Yeah, you could have just saved a map and you could have merged two maps. So that would have been easier, I feel. Like you can define plus operation of two maps and that would have done it directly. इतना हार्ड ओए में नहीं आएगा दादा, ये गलत फैमिली में मत रहो. This is very possible that it comes as the last question of a OA. The last questions of OAs are harder than this question. So I don't know why somebody is saying इतना hard OA में नहीं आएगा. I think तुमने अभी देखे नहीं है OA अच्छे companies के. But I'll send you my Fenwick code. I think that's what Shishtik also did. Okay. Okay. Got it. Got it. Yeah, template hai to I understand. I think recently I've stopped doing with templates. It just tells me, as a teacher, it has helped me to improve my teaching after I've stopped using templates, because now I see it from the lens of how somebody could think from start, maybe. Weekly third problems link. Okay, let me open it up. Yeah, there is Fenwick tree, standard Fenwick tree code. So there are six fake. Okay, I got it. Okay, yeah, it makes sense. If you have template, though, it's as simple as that. Like if you for every number you calculate the depth, and at that Fenwick tree you update at ith position you have a 1. So for every query you go to that particular Fenwick tree's query, and L2R you get a sum. Okay. Clear, everyone? टीम इसमें मुंह लगा क्या मोर एल्गोरिथम के. Yeah, definitely it's easier to code in this case. As long as you can subtract the contribution, you can use Fenwick tree. Okay, cool. So this was the third problem. Where can I get OA questions? mang.in pe hai. I'll just quickly read the fourth problem till then. Okay. Okay. Yeah. You're given a 2D points represent coordinate this number of unique trapezoids that can be formed using 4 distinct points from the points. So 2 पॉइंट का स्लोप रखना है. Interesting. Okay. So I don't know if n's. I think n square should work, but yeah, fraction slow like that. So this is like, I think, parallel line finding thing. Like how many pairs of points have parallel points? given that you don't have any point as common, is what I'm thinking. Like the 4 points should be distinct, right? So how do you maintain that neatly? And the second thing is, what if it's a parallelogram? Hmm. Hmm. Yeah, we calculate the slope, that I understanding. I'm just thinking overcounting wala thing. Kya hai bhai? All points are pairwise distinct. Yeah, I think in the grid, how many different points are there? I mean, like, it's a 2000 cross 2000 grid, right? I mean, we don't have to think about all. So, this is also one observation I'm thinking, that it's a 2000 cross 2000 grid. We don't really need to think about even point wise. I can think about, like, thinking about the first point in certain way, in certain order, by iterating on them in a sorted order fashion, somehow like that, to remove the duplicate counts. Yeah. So trapezium calculation is there, but there will be some overcounting due to parallelograms, and we'll have to remove the parallelograms. The question is, how do you, yeah, how do you basically get the parallelograms? Yeah, makes sense. Right. So in parallelogram, we know that if this is the case, the midpoint kind of coincides, right? So if these two midpoint and these two midpoints coincide, then we might be in for a parallelogram. How do you check for parallelograms quickly? How many how many pairs of points have the same midpoint? Will it give me the number of parallelograms? If if a quadrilateral has if a quadrilateral has same midpoint of the diagonals, is it always a parallelogram? I have to check. I have to check that. But I think it should be the case, because I am not able to think of anything else. Like, so the question is basically find the number of trapeziums minus the number of parallelograms. So rhombus also follows that, right? But it rhombus is a parallelogram, right? अच्छा, so yeah. I think what you mean to say is kite. Zazimus, I think what you are trying to say is what is called a kite. That's a different thing. Rhombus is all sides equal, but not a red square. Their midpoints coincide. Yeah, there is a bisection. So basically, if we, for P1, P2, we find its midpoint, and for another point P3, P4, we find if it's the same midpoint, then these four create a parallelogram. है ना, P1 P2 डबल क्यों करना है, लाइक मेक द कोऑर्डिनेट्स ट्वाइस, सो 0.5 हट जाएगा ना, एनीवेज इंटीजर पॉइंट्स है, या शुड बी, दिस शुड बी डुएबल, दिस शुड बी, डेसिमल क्यों कर रहे हैं, वही एग्जैक्टली मल्टीप्लाई बाय 2 कर दो ना, मतलब मिड पॉइंट इफ x, y is same, so 2x 2y will also be same. So for every pair like just add x1 plus x2 comma y1 plus y2 का मैप बना दो एकदम सीधा हर पेयर के लिए, and the number of pairs that are coinciding, so क्या होगा, इन दोनों का और इन दोनों का सेम आया, मतलब ये चारों मिला के एक क्वाड्रिलैटरल बन रहा है. I think that will give us the number of parallelograms, parallelogram बन रहा है. And trapeziums में we have to find the number of pairs which are parallel. Why don't we do CF tutorials too? Today's E was pretty tough. Yeah, I think I'll have to look at it. Yeah. Sunday ka tutorial, I'm barely able to make it on Tuesday. It's traveling. Sadly, once you get into too many things, जिंदगी में टाइम खत्म हो जाता है. But ठीक है, करेंगे, वो भी करेंगे. I think I can pick some good ideas from CF for sure. Like the next decider problems, जहाँ पर I know any 1600 to 2000 rated person will maybe find it. Placement cell, yes. आजकल मेरे काम यही जाती है जिंदगी में, प्लेसमेंट सेल बिल्ड करना, एचआर से बात करना, लोगों का प्लेसमेंट लगाना, यही सब करता रहता हूँ मैं दिन भर. ठीक है, चलो. So let's get back. So now the question can be solved like this. You have n points. So we have to figure out where is the parallelogram. So I have to figure out 2 points. Uska slope I can get. Like if this is x1 comma y1, this is x2 comma y2. The slope will be y2 minus y1 by x2 minus x1, right? And if there is another 2 points, say some 3 and 4, so y4 minus y3 divided by x4 minus x3, this is also the slope of this. If these two are same, then we can say that they are parallel, or else they are not. Okay. And slope, how do you manage? So when you calculate this fraction, you have to normalize it. I hope you have solved some fraction related problems before this, because what do you mean by normalization? So if it is 6 by 4, it should be equal to 3 by 2. How do you do this? You calculate the GCD of these two numbers and you divide it by that. So GCD is 2, so you divide it by 2 to get this number. Suppose one of them is 0, so you convert like 6. If this is there, so if it is 0 in the numerator, you make them 0 by 1 or make them 1 by 0. So which says it's vertical or it's horizontal. Okay. That is at least how I do it. Like whenever I have to maintain slopes, I convert it to the normalized form, or if of one of the denominators is 0 and 0, I make the other one 1, so that it tells me this is x-axis, this is y, like parallel to, so y is same. So x, this is x parallel to x-axis. This value will tell me parallel to x-axis. This value will tell me parallel to y-axis, and this will tell me exact slope, whatever it is. So then we can check if two numbers have the same, if both of them are parallel to x-axis, then we can say, yeah, and negative things we can like cancel off. Yeah, correct. So this is how you can, and then if two things, if this is 3 by 2 and this is 3 by 2, then we can say that they are both, like, because these are distinct points, so we'll assume that this is, if these slopes are same, then they are non-disjoint. They are two different lines, so we can say that they have the same slope. नहीं, double use नहीं करना पड़ेगा. That's what I'm saying. You will use pair of LL, long LL LL. यहाँ पर रहेगा numerator, यहाँ पर रहेगा denominator. You will maintain them in fraction. Okay. तुम slope को fraction रख सकते हो ना. Fraction can be maintained. I don't know if you know this or not, but code forces fraction class. You just search it. Fraction class. Just search this. क्या है भाई? क्या हो गया भाई? There's some blog I remember. Yeah, this is essentially the code. ठीक है, यही code है. Like you maintain a like whenever you are given a like fraction class a comma b, like you don't need to do this. If it is 0 numerator, just make numerator equal to 1 and then call simplify if it is not 0 wala denominator stuff. Yeah. Okay. Basic this kind of thing should be fine for now as an implementation. वही ओके. तो फ्रैक्शन क्लास डाल के उसको मैप में डाल दो. इफ टू फ्रैक्शंस आर सेम यू विल बी एबल टू गेट इट. बट वो ये कि फ्रैक्शन में फिर तुम्हें लेस देन लाइक व्हेन यू वांट टू कीप समथिंग इन मैप राइट, you have to implement the less than symbol for it or a comparator for it, right? So you have to pick a fraction class and ये हो जाएगा number of trapeziums. बट उसमें अगर सपोज ये ट्रेपेजियम है तो फर्स्ट this is as 1 2 3 4 will get counted and then again same thing as 1 2 3 4 will get counted. Okay, so same thing is getting counted twice. So number of trapeziums you will have to count minus number of parallelograms. How do you count the number of parallelograms? Just find out the number of 4 things that have the same midpoint. That will give me the number of parallelograms and this will give me the number of trapeziums. I'll search you a question. I think I have solved a code forces problem where force parallel lines GCD fraction कुछ तो मिल ही जाएगा यार. I think this should be the problem. पता नहीं ये नहीं है. I think I'll have to search. Okay, I'll have to search. But वही है कि fractions के कुछ questions solve किए होने चाहिए. How to find midpoint? अरे एक मैप लो, ठीक है. मतलब for I equal to 0, I is less than n, I plus plus, ठीक है. एक मैप लिया जिसमें हम लोग रखेंगे एक लाइक पेयर, ये रहेगा मिड पॉइंट और उसकी फ्रीक्वेंसी. ओके, फॉर j इक्वल टू i plus 1, j is less than n, j plus plus. Okay, since all are pairwise distinct, we will do like mp of like arr of I dot x plus arr of j dot x. Now the midpoint will be divided by 2, but we will multiply everything by 2. So arr of I dot y plus arr of j dot y plus plus, right? This will just tell us how many of them are there. Then we will go through for auto v in mp. answer plus equals to v dot second choose 2, right? All, like, if there are these three things having the same midpoint, then you can choose any two lines and it will create a parallelogram. So we choose 2. This will give us the number of parallelograms. This is the code for finding the number of parallelograms. Okay, all well and good, but implementing this is dead. Yeah. No, I think like parallelogram you can calculate, like this much code is there for parallelograms. For fraction, yeah, I think you'll have to do hard work. I mean, I generally do it with pairs only. Like, shouldn't be that hard, yeah. Once you get this, like this, instead of this much same, it will be the same code, except instead of this, it will be reduce ARR of j minus ARR dot y, comma ARR of I dot y, comma same difference for x, right? And this reduce function will basically, convert like some y by x into its normalized form, like either 1 by 0 or 0 by 1 or some x by y where it's irreducible. You have removed the GCD. And since we don't need to sort it, you can just put it in pair. It should be fine. Okay. Either convert like it into 1 by 0, 0 by 1, or x by y where you divide it by the GCD. If it's neither of these two cases, and just make it a pair, return that, and put it into a map. This should be enough, I feel, for this problem. Okay. This will give you the number of trapeziums. Okay. I used array of map, उसमें ये comparator वगैरह भी बना. बाप रे बाप, क्या कर रहे हो भाई? इतना हार्ड क्यों इम्प्लीमेंट हो रहा है? मतलब इक्वालिटी चेक करना है तो पेयर में डाल दो ना. जस्ट मेक श्योर द नॉर्मलाइजेशन वर्क्स करेक्टली. It is easy for me because I have seen this reduce or this normalization before. I have solved this same slope wala question before. But if you haven't solved this, then it will be difficult for the first time to think about how to go about doing this neatly. But most of the time when I implement some new strategy or new thing, I always learn what is the neat way of implementing it as well. Because implementation skills aren't something that people say ki practice karo ho jayega. You have to look at good strategies to improve your implementation. It's not something that automatically comes to you one day. Okay, you have to repeatedly see good implementations to get good at implementation. Okay, so when I solve a problem for the first time, I'm like this is the best, this is a new idea that I've learned. I look at others code, and I try to see what is a better way of implementing this. But for a question which I know the strategy, I don't see others code. That's the differentiation between, like, if I will look into other solution or not. If this is the same thing, I have seen this. If I have seen the same logic before, then I don't see others code. If this is logic is the first time I'm seeing this, then I see others code to see a better implementation. And over time, it kind of compounds very fast to improve. Could implement in the same time. Yeah, I think this slope wala question is expected to be learned over time. Okay, so this was the fourth problem. I mean, this question was probably easy with distinct for everything and all. Finding fixed size windows or using prefix and suffix, comment on that technique. Okay. Yeah, these are like good techniques of finding there. Probability DP was not covered in AZ. It is there in extra videos, but yeah, like I don't take it in classes anymore because not many are like coming these days. Okay. Can you go check CF ka E today? Yeah, we can have a look. Today was क्या educational round क्या? यार अभी hacking phase चल रहा है ना यार. Okay, I think we can discuss the idea. I think this should be a hard problem because not many were able to solve it, which means AI was not able to solve it. So probably this should be a 2100 problem at least. Okay. Yeah, call set of Q complement sums if you can obtain through the following actions. Choose an array, sum S this for each element, add S this to this. So note this is not a multi-set, it's each. So anyways, if the array has duplicate, it doesn't translate into duplicates, right? So it could easily be like this is equivalent to 137 array initially as well. Oh no, no. Oh nice. So some things can be duplicated without the cost in Q. Nice. You would ask you to count the number of distinct sets of complement sums which holds the following. The sum contains the set, this set contains exactly n elements. Each element of the set is exactly equal to 1 to x. Okay. So consider different if there exists an element in the first set that is not included in the second set. Okay, nice. Okay. So if I can think of what goes in over here, if the number of elements I know the gaps. This is 2 gap, this is 4 gap, the gap remains the same, right? You can introduce bunch of zeros. So when I'm thinking about this problem, the first thing that comes to my mind is the gaps remains constant, right? uh, so the way I would approach this problem, let's try to, so I'll not try to solve it, maybe hoga bhi ki nahi, I don't know, but I'll try to think through. I'll just show my reasoning, whatever I'm trying to think, maybe a harder problem. I don't know. I don't think I can solve this also. But let's see. Uh, like first thing that I see is like even though like this is like 4 gap, this is 3 gap, and this is 0 gap. Sorry, 2 gap. This 2 gap and this 4 gap kind of remains over here. So even if you are kind of thinking of the set in 0, 1 to x, so it's like you are putting things in 1 to x. So you can choose what gaps are there in the set, and that should translate with introduce zeros in between, right? Uh, okay. That should be somewhere the observation. अब उसके बाद I have to build on top of it. Like how do you uh, two sets are considered different if exists an element in the first set that is not included in the second set. If there exists a first element in the first set that does not include in the second set. Right. So I have to think about the gaps and I have to think about can I make this gap there? Uh, number of distinct sets of complementary sums. So since each of these would be different, I have to have at least one gap. तो ये numbers बहुत बड़े बड़े नहीं आएंगे मतलब पता नहीं I have to think about it to see one sample at least. It contains one element and the values are up till 7. So there's only this is 1 gap, 2 gap, 3 gap, 4 gap till 5, right? Okay, what gaps are not feasible? What gaps are not feasible to be built? So I think it's basically like we can think about it from the point of view that if you are doing from 0 to x, right? So you have to think about what gap sequence are not feasible to be created. सोचना पड़ेगा अच्छा क्वेश्चन है तो okay. So if you have some A, B, C, let's think about three numbers in the Q set, right? And they are in sorted order, right? So can this be created or not? How do we justify it? So this is how I think you should think. मतलब gaps पे ही कुछ तो बन रहा है from what I can understand. Now I have to think about which gap sequences are feasible or not. That's the first order thinking. Like इससे इस पे कैसे आएगा? First thing I was thinking about exact elements का sum से S से कुछ आ जाएगा. But then these duplicates are changing the S, so I cannot really pivot on S. So then I think about gaps maybe. So इसमें suppose कोई gaps है, how does it translate कि ये feasible होगा नहीं होगा in the bigger sequence? Like some S minus A of I, the largest number probably will get subtracted into this, and the smallest number of the set will get subtracted into this. S minus min will be this, S minus max will be this, right? Okay, so now if I have to think about, yeah, S max to S min, that is there. बहुत मेहनत करा रहे हो तुम लोग यार, कॉन्टेस्ट ही नहीं दे देता मैं बैठ के. एस मैक्स टू एस इन, तो इस रेंज में अगर मुझे वैल्यू बनाना है, सो हाउ डू आई थिंक अबाउट द फीजिबिलिटी, यू नो? See, the overall gap here is some x, you know. So max, like the first element minus last element of the set that you are generating is x. So max minus min is x of the original set, right? So this 2s will at least be greater than, like, s will be greater than 2x. Prime Vivek would have, yeah, obviously that is true. I'm no longer giving CF and all. But ठीक है, सोचते हैं. Max minus min is x अगर मेरे पास है. If the first and last of the sequence is this. So max minus min is this. And why we cannot create 1, 2, 3? Because if we are to create this, the gap between these two elements is 2. So in natural numbers, even if you take gap of two elements, gap of 2, max minus min as 2. So 1 and 3 you have to take. The sum is 4. Number of distinct elements are 3. So you need to have 3 elements at least in this set. So if there are bunch of numbers in the original set and max minus min is some x, even if the smallest number is 1, this has to be x plus 1. And if there are s number of distinct elements over here, then you have to put at least s minus 2 number of elements in between. So कुछ इसका रिलेशन बनेगा यार. If s has to be greater than equal to the number of distinct elements plus 1, even if you put 1, 2, 3, 4 in the set, right, जितने एलिमेंट तुम्हें चाहिए, you have to think about that. आपके अलावा कोई कर भी नहीं पाएगा ना ऑन यूट्यूब. हाँ, यूट्यूब पे तो मतलब कोई ऐसे लाइव ही ट्राई नहीं करेगा, मे बी कुछ लोग कर सकते हैं, 1-2 लोग, बट बहुत ही कम लोग। ठीक है, या तो 1 to 4 कुछ उसका रिलेशन बनेगा यार, मतलब देयर हैज टू बी सम फीजिबिलिटी रीजन एंड उस फीजिबिलिटी का कोई कंडीशन बनेगा एंड उसके ऊपर विल हैव टू डू सम सॉर्ट ऑफ डीपी अकाउंटिंग, मैथ्स प्रोबब्ली, कुछ ऐसे ही मेरे को वाइब आ रहा है इसका। ठीक है, देखते हैं थोड़ा बहुत और, विल ट्राई फॉर दिस। कौन है वो लोग? वो लोग अभी अब और लाइव स्ट्रीम नहीं करते आई थिंक। गिव रोड मैप ऑफ प्रॉब्लम्स फॉर इन आउट डीपी, या सर्च फॉर प्रॉब्लम्स ऑफ इन आउट डीपी को सॉल्व करो। वी आर सॉल्विंग दिस सीएफ का ई वाला क्वेश्चन व्हिच केम जस्ट नाउ। फर्स्ट ग्लांस पे तो मेरे को भी कुछ नहीं आ रहा है ऐसे। ठीक है, ऐसा नहीं यार, हर क्वेश्चन मैं भी कर दूंगा जरूरी नहीं है। ठीक है, ये भी कुछ, ये तो 21-2200 रेटेड प्रॉब्लम होगा फॉर श्योर। एक बार फिर से देखते हैं। The set contains exactly n elements. Oh, we know the number of distinct elements, right? We know the number of elements here. We know that this contains n elements. So original array में at least n elements तो होने ही पड़ेंगे, right? And since here n, there has to be greater than equal to n distinct elements. No, there has to be exactly n distinct elements exactly in the original array. If this is the set, there has to be exactly n distinct elements, and you can replace any element multiple number of times to get the s if you ever want to do that, right? So now if you think about here, you have a b c d, right? So can you generate this or not? हाँ भाई, मतलब I'm no longer claiming कि देखो LeetCode Weekly I take because I am sure that 99.9% of time I can solve all problems. Probably last problem sometimes might come very hard, so I might not be also able to solve, but in most cases I can. But CF पे तो यार EF तो GM level का, मतलब this is like almost at a level where it's hard problem for me, so I don't expect me to be able to solve it always. ठीक है, but I can just give you my thoughts, that's it. ऐसा नहीं, मतलब यू शुड नॉट फील कि अरे ये सामने बैठा ये तो लाइक मतलब ऐसे भगवान है, ऐसा कुछ नहीं है, मतलब मैं भी सीख रहा हूँ, एक देयर इज अ लेवल वेयर आई कैन नॉट सॉल्व आल्सो, बट at least for your level I can teach enough. Okay, so if there are 3 distinct elements, you should have 3 distinct elements and some elements might be repeated. Okay, so if there is 3 distinct elements, so there are 3 different gaps, x, y. So if n distinct elements, so there are n minus 1 gaps. So there will be n minus 1 distinct gaps over here also. Okay. So how do you then think about? बस इसका हमें एक फिजिबिलिटी कंडीशन चाहिए। आई एम वेरी श्योर कि यहाँ पर कोई एक फिजिबिलिटी कंडीशन की बात हो रही है। आई एम वेरी वेरी श्योर अबाउट इट। व्हाट इज दैट? इफ देयर आर n एलिमेंट्स एंड तुम यहाँ पर 1 से भी स्टार्ट करो, 1 2 3 4 n डिस्टिंक्ट एलिमेंट, तो अब टिल n तो तुम्हें जाना ही पड़ेगा। तो द s इज ऑलवेज ग्रेटर देन इक्वल टू n into n plus 1 by 2, worst case, right? So if this is s and this is the smallest possible distinct value set that you can create, -1 से लेके -n, this is the range that you can play in. Okay, the sum can only increase. So this is the range that I am getting where I can get a feasible value, and I can increase my sum indefinitely. So this can increase indefinitely, but this is the lower threshold. मतलब I can keep increasing this. This is the minimum possible value. This is the, you can keep increasing this value, but you cannot go less than this. So the smallest possible value that you can create in the set is this. This can be my first observation. Yeah. Yeah. Even if both bound doesn't move, like we are generating the smallest possible set जिसका largest value ये है. And there are n distinct, so at least the gaps एक का gap रखा है. So I think you cannot go less than this, I feel. ठीक है. We can do some small enumeration and try to see कि possible है नहीं and all these kind of things. But yeah, I don't think this should be possible. जैसे n equal to input देखते हैं. N equal to, say this. So if n is equal to 2, 2 into 3 by 2, 3 minus 2 1 ही आ रहा है यार. तो मिनिमम वैल्यू कैन बी 1. इफ n इज इक्वल टू 3, तो अगर इसका वैल्यू 3 है, so 3 into 3 plus 1 4, 6 minus 3 3. I don't know like if they have given the 34 values, but I don't think we can generate less than 3 in this. Yeah, I don't know if I can generate 3 from this or not. Okay, तो ऐसा कुछ बन तो रहा है. तो n पे एक बाउंड आ रहा है, x आ रहा है. So now we have something like कुछ n to x में कितने number of way है you can generate these gaps. Okay. So if you can go from n into n plus 1 by 2 up till x, no, minus n to x, and you have to sample n distinct values. तो x plus n minus n into n plus 1 by 2 आ जा रहा है ये चीज. This is the plus 1. This is the scope. And in these many numbers, I have to choose n distinct values. Choose n. I know. Will all of them be always generatable? I think from this we can shift and duplicate some values to create all possible sequences. वैसा बहुत vibe आ रहा है कि we can always shift and duplicate and generate something like this. ठीक है, चलो अब मैं बैठ के प्रूफ नहीं कर रहा. अब तुम लोग आगे प्रूफ करना, देखते हैं यार. हैकिंग फेज में है ना, अब तो हम कर सकते हैं. I think it might be complicated than that, but I'm just giving you what my thoughts are. I have not really proved it exactly, but इस range में I have to choose n distinct elements. What can be my visible? नहीं ये अब लीड कोड वीकली खत्म हो गया है, अब हम कोड फोर्सेस पे आ गए, है ना. देखते थोड़ा कुछ तो भी हार्ड ही लग रहा है मेरे को ये बहुत हार्ड है यार. अच्छा मैंने लॉग्ड इन ही नहीं हूं मैं. ठीक है, जब हो जाएगा तब करना है यार. आई डोंट वांट टू look into this for now. I don't want to get into like proving something right now. I might be wrong. I'm just thinking this might be the first glance what I might try, right? And when we are given like 3, 10, like let's do ना. अब जब खोल ही लिया है क्वेश्चन तो भाई Yeah, question. When you are given this 3 comma 10, so if you put 3 plus 1 plus 10 minus 3 into 3 plus 1 by 2, this is 2 6, 3 plus 1 plus 10 minus 6 minus 3, I don't know, minus 6, sorry. Choose n is 3. So this will be what? I don't think, मतलब थोड़ा और कुछ इसमें pointers होगा. I'll have to see. ठीक है. This will be what? 8 choose 3. 8 into 7 into 6 by 3 into 2 into 1. 8 6 of 54. 8 7 of 56, sorry. And answer क्या है? आंसर तो 34 है. तो कुछ और केसेस होगा, सोचना पड़ेगा अब क्या हटाना है इसमें से. ठीक है ना. Why are certain not possible? 34 आ रहा है आंसर. What are we missing? So some more observation now. Next, अब मुझे next gen of operation फिर से observation निकालना पड़ेगा. एक तो ये रेंज ऑफ मेरी feasibility है. उसके बाद I have to generate कि what kind of gaps are feasible. Can you generate really 1 2 3, like 3 4 5 6? मतलब अगर मेरे को उस क्वेश्चन में दिया हुआ है ना कि I have to generate 5 distinct values, sorry 3 distinct value between, so can I generate 3 4 5 is what I have to think. 3 आया था मेरा minimum feasibility, 3 4 5. So for this to be the set, I have to find out whether there exists a complement set or not, है ना. should be checkable. I'll have to, यही है मतलब, can you, how do you check? इसका एक अच्छा कुछ लॉजिक बनाना पड़ेगा that if this is gap is 1, this gap is 1, there are like at least 3 elements, this gap is 1, this gap is 1. Okay, so I'll try to start with 1 and इसको 2 रखना पड़ेगा, इसको 3 रखना पड़ेगा, so the sum is 6 and 6 minus 1 is 5, 6 minus 2 is 4, 6 minus 5 3 is 2. तो ये generatable है. Now if I make this 6, तो ये gap 2 है, so this gap becomes 2, this gap becomes 1, so this has to be at least 3, this has to be at least 4, right? So the minimum possible sum that you get is, like if this is x and there is a sequence of gap that you are trying to check, you will know that what is the sum of the elements and you can check if it is feasible to generate that way. मतलब कुछ तो ऐसा ही लॉजिक है इसमें. So if you are having this one, like, so the sum will be how much? How much will be the sum? 1 3 8, and 8 minus 1 will be 7, 8 minus 3 will be 5, 8 minus 4 will be 4. So if I just make this all, so I cannot generate this, right? I cannot generate this if I am having this. So if this is 1 and the sum of gaps is x, okay, I think I got some logic. Okay, if this gap is p1, if this gap is p2, if this gap is p3, है ना, the first number can at most be this n into n plus 1 by 2 minus n, and even if these gaps are there, you know the sum of these values how it's going to be distributed, and we have to check somehow कि क्या feasible नहीं है उसके बाद. बस आजकल इतना बहुत है. अब इतना मत दिमाग चलाओ मेरा बैठ के, मतलब ये feasibility चेक करनी पड़ेगी केस बाय केस. आई थिंक ऐसे ये डिराइव्ड होगा एंड देयर विल बी सम फाइनल कंडीशन कि ये सारे, मतलब if the sum of gaps is some y, तो from this, like what is the condition of feasibility, और फिर ये y का कुछ तो भी dp बन जाएगा to distribute among the n numbers. You have to distribute y gaps in these n minus 1 gaps, कुछ तो ऐसा वे में such that it is feasible. That should be the intuition. अब एडिटोरियल बाकी चेक कर लेना ठीक है हो गया यार अभी मैं 30 मेरे को भी लग जाएगा 30-40 मिनट्स लग जाएगा it is not a easy question but just giving some observations here. Okay, chalo, cool. I think this is where we'll stop for today. I have to leave, like, kind of turn it off by 12. Okay. But thanks for joining in, everyone. Kuch nahi to yaar, I hope you guys learned at least things from this lead code wala thing. Is it virtual contest? No, it is today's contest. It's educational contest. Today's I was just trying to think of what ideas can come in mind. किसका कोड? इसका कोड ये तो बताया ना कैसे करना है. लिखो इम्प्लीमेंटेशन. भाई कोडिंग के लिए क्यों आ रहे हो मेरे स्ट्रीम में? ये तो अब तो जीपीटी भी लिख देगा. ओके, योर नेक्स्ट क्लास इन इज इट. डिड यू हियर रिप्लिट डिलीटेड एंटायर डेटाबेस ऑफ अ कंपनी? नहीं भाई, ये सब नहीं थे. ओके, अगर कुछ भी दिक्कत हो इम्प्लीमेंटेशन में तो जैजिमस इम्प्लीमेंट करके भेजोगे, ठीक है? जैसे बस एक बार इसका लाइक ये जो मैंने लॉजिक बोला फोर्थ वाला एंड जो ट्रेपेजियम पैरेललोग्राम वाला करा उसका एक बार इंप्लीमेंट करके सेंड मी. आई विल सेंड इट इन द स्लैक ग्रुप, सॉरी टेलीग्राम ग्रुप. ठीक है, इंप्लीमेंट दिस वंस. हाँ, जो मैंने अभी लाइक ये जो सेकंड वाला आइडिया बताया एंड ट्रेपेजियम एंड पैरेललोग्राम वाला आइडिया बताया, ट्राई टू इंप्लीमेंट इट एंड सेंड इट टू मी. मतलब इन योर ओन वे बट इंप्लीमेंट द सेम स्ट्रेटजी दैट आई टोल्ड इन क्लास. ओके, yeah, send it on LinkedIn. I'll send it on the Telegram too. Okay, cool. Chalo. Yeah. Okay. Cool. That will be all for today. Thank you for joining everyone. I hope you guys enjoyed the stream. Next live again, next contest. जब मुझे कोई अच्छा problem दिखेगा, I'll be back to discuss it. When I feel कि यार there is truly some value I can bring in this live, I'll have this stream again. Till then, I'll see you all. Placement cell AZ से हो जाएगा ना placement. यार कोशिश तो कर रहे हैं यार बहुत. For those who don't know, there is a new cohort starting from 9th of August. Right, so if you are looking for that, you can join. Maybe I'll make a dedicated video for AZ and all later on. Chalo, that's all for today. Thanks for joining in. Bye bye and have a good night.